Hi, my name is Doro Bischoff, and when I'm not outside with this little guy, I'm working on my PhD thesis at the Institute for Geophysics and Extraterrestrial Physics in Braunschweig, Germany. You just stepped into my contribution to the EPAC EPSC video contest, #Planetary Science for All. My research is related to these beautiful phenomena we could recently observe, Comet Neowise. Another one was visited by the Rosetta mission and brought a bunch of new data. But I do experiments in the lab concerning the tensor strengths of microgranular organic material. Why and how, I will show you now.
Let's start with comets in general. These guys are dark bodies out there in the solar system, like this pretty one called Chury, visited by the Rosetta mission. They consist out of ice and dust, and here we focus on the dust. Especially, it contains minerals and organic stuff. As these minerals were studied before, the spotlight is now on organics. Anyway, it's nearly half of the comet's dust. And as we aim to do simulation experiments with the comet in the lab, we need material which is useful for this aim. We choose graphite, paraffin, humic acid, brown coal, and charcoal. Okay, organics, check. But we wanted to measure something, and this was the tensor strength.
What is a tensor strength? It is easy to illustrate because it's the strain a material can withstand when you pull it apart.
But why do we care? There are several reasons. First, in the formation of comets and planetesimals, dust grains collide and stick together. You can imagine, if the material has a low tensor strength, it is very unstable and sticking together is unlikely, so it's an important measure to understand the formation processes. On the other side, there is cometary activity. The reason for the pretty clouds of dust and gas called coma and the cometary tail. Again, if the tensor strength is low, it is very easy for the gas that flows out of the comet due to the sun's heat to take dust particles with it. Now we are ready to measure the tensor strength, but how, as the material is granular? With the Brazilian disc test and a small trick. Take the material, press it into a cylinder, and then put it on top. Worked, so be happy! In the video you see that the samples break apart and at which pressure is measured with a scale underneath, and you get a plot like this. After several tens of measurements we did some calculations, but time is limited, so we just have a look at our final results. Here we are. I really don't want to go into detail, but two important things I want to highlight. As you may see, there are some very high values, e.g. compared to the mineral silica, for graphite and paraffin. But there are also very low values, for the coals for example. This big range is surprising and interesting, and it is also very useful to pick a material we can use in the COFI-Lab project for the simulation experiments of comets.
This was my work on the tensor strengths of microgranular organic material. And in this title I stated a question, sticky or not sticky? And the answer, it can be both. Thanks for watching, and if you are now interested in the work of the COFI-Lab project, visit us on Twitter or YouTube.